In this segment, we are going to learn about different pretreatment for anaerobic digestion feedstocks. So under subcategories, it comes objectives or benefits of pretreatment, or why should we apply the pretreatment, and then different pretreatment categories. Let's look at the objectives of pretreatment. But first, we should keep in mind that selection of pretreatment plays a very significant role on overall process chain and process efficiency. The final process outcomes and economics are dependent on that. So with that in mind, in general, pretreatment are adopted if they fulfill any or multiple of the following objectives or offer multiple benefits, such as they remove toxic, inhibitory, and unwanted substance for digestion. They reduce digester maintenance and cleanup. They homogenize the feedstock mixture so that the digestion process gets easier. They adjust moisture content, temperature, etc. of the feed for digestion process. They enhance biogas production from the digester. They promote higher organic and volatile solid destruction inside the digester. They reduce feedstock volume and thus increase digester holding capacity. They increase hygienic safety and decrease pathogen content of the feedstocks, or they decrease processing and disposal costs of the end products. Let's move to pretreatment categories. The type and level of pretreatment mainly depends on the characteristics of the feedstocks. Some of them are high in impurities such as grit, sand, stone, metal piece, etc. Some contain harmful microorganisms and pathogens like slaughterhouse waste, animal waste, and some of them are high in lignocellulosic compound that need to break down for effective digestion. So based on the target or objective, pretreatment can be generally divided into the following three categories. Pretreatment targeting sorting, separation, and homogenization, targeting pasteurization and pathogen reduction, and targeting hydrolysis enhancement and process improvement. And we're going to discuss in these three categories in more details in the following slides. Let's look at the pretreatment that provides sorting, separation, and homogenization. So the first step of pretreatment is to remove non-biodegradable and inert material that can be negatively affect downstream processes and equipment, like bigger piece of paper, plastic, clothing metal piece, rocks, etc. And they can be manually sorted at the receiving station of the treatment plant. And some of the mechanical separation equipment are also available. They provide this job, such as stone trap. They collect rocks and gravel from inflow. Grit tanks that allow the settlement of sand, grit, stones, and broken glass. Screen. There's a screen image at the side, and that takes also the bigger pieces of contaminants from the inflow. Rotating trammel screen, also shown in the picture, that feed materials spiral down the rotating drum and the undersized material passes and the oversized exits. Magnetic separators, they are sometimes required for MSW or organic fraction, and they can be installed on top of a conveyor belt to collect metal scrap and pieces. And some of the other commercially available separation units for pretreatments are horizontal separator by Highbag, vertical bioseparator by Doda, hammer mill separator from Walker Power, vertical chain mill plus piston press by Phytech. Some of the commercially available homogenization system for mixing and coarse grinding are BioCat, QuickMix, EnergyJet solid material feeder, etc. from Vogelsang, and multi-crusher, multi-chopper, power feed SSR from Borger. So I have given the link of this commercially available equipment. I'll suggest you to go to these sites and links and get yourself familiar with this treatment units and see what type of, how they look like, how they work, and what type of purpose they serve. And that will enrich your knowledge about the pretreatment products and commercially available units. Let's look into the pasteurization and pathogen reduction category. Any feedstock that contains pathogen or infectious microorganism need to go through some level of pretreatment for sterilization or pasteurization based on the degree of contamination. Sterilization can be achieved by at least 20 minutes of exposure at a core temperature greater than 133 degrees centigrade and an absolute steam pressure of no less than 3 bar. On the other hand, pasteurization is critical for waste-containing animal byproducts and required at least 60 minutes in the temperature range of 70 to 90 degrees centigrade. One such commercially available unit is batch up hydrogenation unit by Landia. So as per the manufacturer website, it is a completely freestanding unit for mixing and heat treatment of the feedstock and available in various sizes. When the feedstocks are added, it is comminuted, liquefied, heat treated and pumped back out in one process. You can go to the manufacturer site and get more knowledge about this product. Let's move to the third or the last pretreatment categories, that is hydrolysis enhancement and process improvement. It is widely stated that hydrolysis is one of the rate limiting steps for anaerobic digestion, especially in the presence of complex organic compounds in the feedstock. In general, feedstock pretreatment method for hydrolysis and process improvement can be further categorized as following: physical and mechanical pretreatment, physiochemical and chemical pretreatment, thermal pretreatment, biological and enzymatic pretreatment. So from the name you can understand that when you apply only physical or mechanical pressure or forces, that is under physical and mechanical pretreatment. When chemical and physical pressure both are added, that is goes under physicochemical and chemical pretreatment. When heat is used, that goes under thermal pretreatment. And when enzyme or other microorganisms are used for pretreatment, they goes under biological and enzymatic pretreatment. So let's look into those 4 different groups a little bit more closely. Physical mechanical pretreatment. Physical mechanical pretreatments are mainly consisting of chopping, grinding, milling, ultrasound, microwave radiation, etc. to reduce the overall particle size of the feedstocks. Advantages are higher exposed surface area of feed, resulting in higher microbial access and degradation. So increased cell rupture and release of organics in the solution equal better biodegradability and higher gas production. Example of some commercially available technologies under this pretreatment category is Sonolyzer by Vivo. It's an ultrasound sludge disintegrator and used for pretreating secondary sludges. Physicochemical and chemical pretreatment. Physicochemical or chemical pretreatment consists of steam explosion, application of alkaline solutions such as sodium hydroxide, calcium hydroxide or ammonia, treatment with ozone treatment with acid such as dilute sulfuric acid, acetic acid and nitric acid, etc. The aim of chemical pretreatment is to break down the complex organic compounds to simpler structure that are more hydrolyzable during the digestion process. Example of commercially available technologies are microslides. First, a portion of secondary sludge is pretreated with lime to soften cell membrane. Then pressurization and abrupt pressure drop rupture the cell membrane, followed by grinding, mixing, and liquefaction. Thermal pretreatment. In thermal pretreatment, feedstocks are subject to higher temperature in the range of 40 to 175 degrees centigrade to accelerate the hydrolysis process by breaking down the long chain biomolecules. Example of commercially available technologies can be thermal hydrolysis process. Here hydrolysis takes place in a reactor at 165 degrees centigrade for 20 to 30 minutes and under high pressure and temperature organic compounds dissolved, hydrolyzed and sterilized. Biological and enzymatic pretreatment. A specialized microorganism or specific enzymes have also been used to enhance hydrolysis. Enzymes such as lipase, proteinase, cellulases, and hydrolases have been reported to accelerate hydrolysis in the literature. Several fungi such as brown, white, soft rot fungi have been used for pretreatment of lingocellulosic feedstocks. The main advantages of biological pretreatments are lower energy requirement, no chemical requirement, and mild environmental conditions. But for most biological pretreatment process, the treatment rate is very low. Let's move to pretreatment of food waste and organic fraction of municipal solid waste, OF/MSW. Effective pretreatment of food waste and organic fraction of municipal solid waste are essential. This waste needs to be free of contamination like plastic and other packaging materials, cardboard, metal pieces, wood particles, glass pieces, etc. They also need to be converted into a homogeneous organic mixture suitable for anaerobic digestion process. So depending on the level of impurity and sources of the product, food waste and OF/MSW feedstock may be required different combination of the following pretreatment technologies, like receiving and manual sorting, bag opener, shredder, screw cutter, milling, rotating drums, rotating trommels, screen, magnetic separator, sterilizer, pulper, hydrolyzer, and homogenizer. Here are some examples of food waste and OF/MSW pretreatment plants that are commercially available, like BioPre plant system, the design for pretreatment of food waste, and then pretreatment plant by spiral tanks. They use a number of proprietary process components to produce a biosubstrate feed for digester that is free of plastic and other unwanted reject fraction, and Sysav's pretreatment plant for food waste. Their food waste is converted into pumpable viscous slurry as the end product. So I'll suggest you to go to this link and get yourself familiar with this type of pretreatment plants, and you will get an overall idea what type of pretreatment plants do and what are the units they are composed of. So that will give you a better knowledge of the pretreatment technology and commercially available technologies. With this slide, I'll close this segment, and then we'll move to our next segment, I think the most anticipated one, and it is about process design, anaerobic digestion process design, and we'll continue from there.